In the summer jobs problem, the goal was to operationally define a construct which cannot be measured directly. One such construct is worker productivity. Other such constructs that we'll encounter in this course include measures of nonlinear distances and measures of centrality, spread, density, distribution, strengths of correlation, chance, error, and levels of significance. One main point will be that there almost always exist several ways to operationally define such constructs, and different definitions often lead to significantly different results because each is based on different assumptions. For example, to measure worker productivity, you first need to measure quantities such as hours worked and dollars earned. Then, there are several sensible ways to combine these quantities, each of which is based on different assumptions about the factors and relationships that should be emphasized. This Tinkerplots worksheet shows 3 ways that students often use to think about worker productivity in the summer jobs problem. However, to make it easier to investigate alternative approaches to this problem, no information is given about slow, steady, and fast periods of sales. But, the data are randomly generated so that it is possible to observe results over a large number of samples. And, data are given for 12 workers instead of just 9. The 3 ways of thinking about worker productivity are as follows. 1. First, calculate the average dollars and the average hours across June, July, and August. Then, divide the average dollars by the average hours to get average dollars per average hours. 2. First, calculate the dollars per hour for June, July, and August. Then, calculate the average of these 3 rates. 3. Create separate graphs showing each worker's dollars per hour for each month, June, July, and August. Then, look at trends across these 3 months, and, perhaps give more weight to the scores in August, because August shows how the worker was doing at the end of the summer. Then, to investigate how productivity scores might vary for any given worker, one way to click on this worker in any graph, and her scores also will be highlighted in other graphs, as well as in the table at the top of the worksheet. Another way to see instances where some worker is assessed differently using the 3 methods is to change a graph by dragging down a new quantity from the table. For example, these 2 graphs show the results for the 2 situations. 1. When you calculate averages first and then find the rate of these averages, and 2. When you find rates first and then find the average of these rates. So, to see how these 2 methods give different results, just drag down one quantity into the other graph. Then, notice any workers whose position changes in the new graph. For instance, for this set of data, notice how Jenny's ranking changes in the 2 graphs. To further investigate interesting cases, click on this case in any of the graphs and then look at the case that is highlighted in other graphs. For example, in this graph, Jenny scores low in June and July. But, she scores high in August. So, her productivity is not consistent across the 3 months. When you develop formulas or methods for measuring attributes like the productivity of workers, what you are doing is called operationally defining the construct. Operationally defining attributes that cannot be measured directly is in fact one of the most common things that people do when they engage in mathematical thinking beyond school. It occurs when people develop ways to measure the achievements of students in a class based on scores from quizzes, tests, projects, or other assignments. Measure the success of teams or players in sports contests. Measure the productivity of workers or businesses. Measure the fuel efficiency of automobiles. And so on. When statistics is used to measure attributes associated with collections of data, it often makes a huge difference how you decide to operationally define distances, centrality, spread, error, or the predictive power of inferred trends. And, every operational definition de-emphasizes some things in order to emphasize others. Every operational definition is based on assumptions. And, what is important is to make sure that the assumptions that underlie your statistical analyses are consistent with assumptions that you really hold.